If each angle has the given measure, is in standard position, determine the quadrant in which its terminal side lies. You might choose to find a coterminal angle if the angle that you're given is not inside of one positive revolution. If you don't want to do this, you don't have to. So we could, since this is negative 8 pi over 3, add to this a complete revolution. One complete revolution would be 2 pi. 2 pi as a fraction would be 6 pi over 3. If we did that, that would not be enough to give us a positive answer. So we're going to add 2 revolutions to this. So if 6 pi over 3 is 1 revolution, that means 12 pi over 3 would be 2 revolutions. If I added those together, I would get 4 pi over 3. Negative 8 pi over 3 and 4 pi over 3 would have the same terminal side. So where does that fall in the coordinate plane? Well, if we start here on the positive x-axis and we say that's 0 pi over 3, a complete revolution, back to where we started, would be 2 pi, which is 6 pi over 3. Half a revolution would be half of 6, which would be 3 pi over 3. Halfway between 0 and 3 would be 1.5 pi over 3. Notice the numerators go from 0 to 1.5 to 3, so the next one's going to be 4.5, adding 1.5 pi each time. So this angle, which is 4/3 pi, would be down here in quadrant 4. Had you stuck with the original angle, negative 8 pi over 3, that would have been 2 revolutions in the negative direction, and then putting us right here in the same spot. So the answer to this is quadrant 3. Supposed to figure out what quadrant the terminal side lies. If the angle is in standard position, then the initial side is on the positive x-axis, like so. If we go negative 167, that's clockwise. So if we start here at 0, this would be negative 90. This would be negative 180, which makes this angle here negative 167. That's in quadrant 3. So this answer is quadrant 3. I'm supposed to figure out where the terminal side lies of an angle in standard position. So a complete revolution is 2 pi. Using a denominator of 8, like this problem has, that would be 16 pi over 8. Halfway around would be 8 pi over 8. So hopefully you can see here that would put us in quadrant 2, because 7 pi over 8 is almost 8 pi over 8. So this answer is quadrant 2. If you need more of an explanation, I'll give you a little one here. Starting here on the positive x-axis is 0 pi over 8. Halfway between 0 and 8 would be 4 pi over 8. So hopefully you can see then that 7 is between 4 and 8. So that's in quadrant 2. Where is the terminal side of angle 227 if the initial side is on the positive x-axis? So here's the initial side. It's going to put us in quadrant 3, because this is 90, 180, 270. This over here is 0 degrees and 360 degrees. 227 is between 180 and 270. So it's quadrant 3. Number 5, you're supposed to find where the terminal side lies. Lots of different ways to do these problems. One method here would be to mark each quadrantal angle. So we got 0 pi over 3. Halfway around would be 3 pi over 3. All the way around would be 6 pi over 3. Positive y-axis is halfway between 0 and 3, which would be 1.5 pi over 3. So notice the numerator is increasing by 1.5, 0 to 1.5, 1.5 more, 1.5 more would be 4.5 pi over 3, 1.5 more would be 6. We can continue and keep adding 1.5 if we wanted. That would give us 7.5 pi over 3, and then 9 pi over 3, then 11.5 pi over 3. No, that's not right. 10.5 pi over 3, and then 12 pi over 3, and then 13.5 pi over 3. Once we get to that point, and that puts us here in quadrant 1. So the answer is quadrant 1. If you don't like going around and round and round and round and round like that, then find a coterminal angle by taking the 13 pi over 3, subtract a complete revolution from it, which would be 6 pi over 3. That would give you 7 pi over 3, which is still more than one complete revolution. So if we subtract 6 pi over 3 from that, end up with pi over 3, which we can see is going to fall into quadrant 1. Supposed to figure out where the terminal side lies. It's a negative 730 degrees. You could find a coterminal angle that's positive by adding 360 to it, and 360 again, and 360 again. That's an option. Another way to do it is to say, well, I'm starting here at 0, and I'm going to go backwards. If I go backwards a complete revolution, I'm at negative 360. If I go another complete revolution, I'm at negative 720. The angle we're given here is negative 730, which is just 10 more degrees from that. Puts us in quadrant 4. Number 7, I'm going to choose to do this one by finding a coterminal angle. Once again, not the only way to do it. So I'm going to take my negative 3 pi over 5, add a complete revolution to it, which would be 10 pi over 5. That's the same as 2 pi. And that would give me 7 pi over 5. Where does that fall in the coordinate plane? If we start here at the beginning, 0 pi over 5, make a complete revolution, that puts us at 10 pi over 5. Half a revolution puts us at half of 10, which is 5 pi over 5. Halfway between 5 and 0 would be 2.5 pi over 5. Notice the numerators are increasing by 2.5 each time, which means down here we got 7.5 pi over 5. So the angle that we're drawing is 7 pi over 5, which is between 5 and 7.5, so on quadrant 3. Number 8, trying to figure out where the terminal side lies. If we chose to, we could find a coterminal angle. Coterminal angles are found by taking complete revolutions and adding or subtracting it to our angle. This angle is in radians. I'm going to add a complete revolution to this, which is 10 pi over 5. If I do that, I get negative pi over 5. If I still want it to be positive, which you could graph it like this if you wanted, but if I wanted to be positive, I could add another revolution to it, which is 9 pi over 5. Almost 10. 10 pi over 5 is 2 pi, which is the positive x-axis. It's going to put us here, which is quadrant 4. If you need more of an explanation, let me give it to you. At the beginning, we're at 0 pi over 5. Complete revolution would be 10 pi over 5. It's in the same position. Halfway around is 5 pi over 5. Halfway between 5 and 10 is 7.5 pi pi square roots of 5. 9 is bigger than 7.5, but it's less than 10, so we're in quadrant 4. Change each degree measure to radian measure in terms of pi. So we have 200 degrees. We need to multiply this by 1. If you multiply by 1, it doesn't change its value, it just changes the way that it looks. I'm going to write my 1 in the form of 180 degrees over pi, under pi. Pi is in radians, 180 degrees is in degrees. Pi radians is the same as 180 degrees, so you can write that as a fraction, as 1. Anything divided by itself is 1. You could also write 2 pi radians over 360 degrees, same thing. Simplifying this, you can divide the top and the bottom by degrees. You can divide 200 and 180 both by 10. Gets rid of the 0. And you can divide 20 and 18 both by 2. It gives you 10 over 9. Left with on the top 10 pi radians and the bottom 9. So we get 10 pi over 9 radians. Number 10 is supposed to change 150 degrees to radians. So we're going to multiply it by pi radians over 180 degrees. You can divide both negative 150 degrees and 180 degrees by degrees. You can divide them both by 10. You can divide 15 and 18 both by 5 and get negative 3, pardon me, not by 5. Let me rewrite that. You can divide negative 15 and 18 both by 3 and get negative 5 over 6. So that's going to give us negative 5 pi over 6 radians. Change the degree measure to radian measure in terms of pi. So we're going to multiply this by pi radians over 180 degrees, because pi radians is equal to 180 degrees. We can divide both 75 and 180 by 5. Better than that, we can divide them both by 15. 75 divided by 15 is 5. 180 divided by 15 is 12. You can divide degrees by degrees. You end up with 5 pi radians over 12. Number 12, convert 105 degrees to radians. So we're going to multiply it by pi radians over 180 degrees. The degrees cancel, so you can divide it by the top and the bottom. You can divide 105 by 15. It goes 7 times. You can divide 180 by 15. It goes 12 times. This gives us 7 pi over 12 radians. 13, we got 570 degrees, supposed to convert it to radians. We're going to multiply it by pi radians over 180 degrees. You can cancel the degrees out. You can divide 570 and 180 both by 10. You get 57 over 18. You can divide 57 by 3. And you can divide 180 by 3. 180 divided by 3 is 6. 57 divided by 3, I believe, is 19. That gives us 19 pi radians over 6. 14, change negative 450 degrees into radians. We're going to multiply the top by pi radians and the bottom by 180 degrees. Degrees cancel. You can divide both those by 10. Negative 45 and 18, you can divide both by 9. Gives us negative 5 over 2, which gives us negative 5 times pi over 2, and that's in radians. If you write no symbol, it means radians. If you write a symbol like degrees, it means degrees. So we could write radians here, we don't have to. So it's to change 405 degrees into radians in terms of pi. So we're going to multiply top by pi radians and the bottom by 180 degrees. The degrees cancel. We could divide both 405 and 180 by 45. 45 goes into 405 9 times. 45 goes into 180 4 times. It's going to give us 9 pi over 4 radians. So to convert negative 1,250 degrees into radians. So we're going to multiply it by pi radians over 180 degrees. You can divide the top and bottom by degrees. You can divide the top and bottom by 10. 125's only factors are 5 and 5 and 5. 180's factors are 2 and 9. So this does not reduce. Change each radian measure to a degree measure. And then it says if you have any decimals, converts to minutes and seconds. Pi over 3 is in radians. I want to get rid of my radians. I'm going to multiply the bottom by pi radians. What's equivalent to pi radians? 180 degrees. Pi's cancel. I can divide 3 and 180 both by 3. Radians cancel. End up with 60 degrees. Number 18, I have negative 3.5 radians. I'm supposed to convert it to degrees. I want the radians to cancel, so I'm going to put pi radians on the bottom. What's equivalent to that as degrees is 180. No pi on my negative 3.5 to cancel, so I still have a pi. I can divide my radians. 180 times 3.5 is 630, so this is negative 630 degrees divided by pi. Nothing cancels. The direction says if you have any decimals, convert to minutes and seconds. So I'm going to divide this by pi, and I get something like this. I say something like because it's an irrational number. Negative 200.5352283 degrees. That's a negative 200 whole degrees. I'm then going to take the decimal part of this and multiply it by 60 to convert that to minutes. Gives me 32 full minutes. When I multiplied that, I got 32.1136975. I'm now going to take this decimal and multiply it by 60. Gives me 6.8. Rounding to the nearest second, that would be 7. Seven seconds. 2 hash marks for seconds. We're supposed to take 4 pi over 3 radians, convert it to degrees. To get rid of my radians, I'm going to put pi radians on the bottom. That's equivalent to 180 degrees on the top. Radians cancel, pi's cancel. You can divide both 3 and 180 by 3. End up with 4 times 60. That's 240 degrees. Number 20, we got negative pi over 2 radians. Just to convert to degrees, so I'm going to multiply it by 180 degrees over pi radians. My pi's cancel, my radians cancel. I'm going to divide both 2 and 180 by 90. By 2. End up with negative 90 degrees. .75 radians. Change it to degrees. I need to get rid of the radians, so I'm going to put pi radians in my denominator. That's equivalent to 180 degrees, so I put that on top. Radians cancel. Nothing else does. 180 times 1.75, using a calculator, I get 315 degrees divided by pi. If I divide that by pi, I get approximately 100.2676141 degrees. The directions: convert any decimals to minutes and seconds. I take the whole number of this, 100, and say that's how many degrees I have. I take the decimal part and multiply it by 60 in my calculator. I end up with 16 full degrees, and I have this decimal left over. I take that decimal and multiply that by 60. And it gives me 3.4 minutes to the nearest second. Pardon me, it gives me 3.4 seconds. The nearest second, it's 3. And this symbol right here should not be a degree symbol. That should be minutes. I apologize. So we got 100 degrees, 16 minutes, 13 seconds. Supposed to change the radian measure to degrees. So we're going to multiply this by 180 degrees over pi radians. I want pi radians on the bottom, so the radians cancel. In this case, the pi's also cancel. You can divide 12 by 12 and get 1. You can divide 180 by 12 and get 15. That would give us negative 105 degrees. Supposed to convert 17.64 radians into degrees, so we're going to multiply this by 180 degrees over pi radians. Radians cancel. 17.46 times 180 is 3,142.8 degrees over pi. Putting that into a calculator, we get approximately 1,000.38431 degrees. The directions: convert any decimals to minutes and seconds. So we have 1,000 full degrees. We take this decimal, multiply it by 60, and we get 23 minutes. And then after the 23 minutes, we get this decimal. Take that decimal and multiply that by 60, and that will give us 3.5 seconds to the nearest second. That would be 6. Supposed to change 17 pi over 6 radians into degrees. So I'm going to multiply the top by 180 degrees and the bottom by pi radians. Pi radians cancel. You can divide 6 by 6 and get 1, 180 by 6 and get 30. 17 times 30 is 510 degrees. 25 says, find one positive angle and one negative angle that is coterminal with each angle. Coterminal means they share the same terminal side. Coterminal angles are always a complete revolution apart. Complete revolution in degrees is 360 degrees. If you add those, you get 300. To find a negative coterminal angle, we could subtract a complete revolution or a multiple of a complete revolution. So we get these two answers. There's more answers than that. Those are just two possible answers. Supposed to find some coterminal angles. Coterminal angles are complete revolutions apart. Using radians, a complete revolution is 2 pi. 2 pi written with the same denominator as this 12 would be 24 pi over 12. So if I add these, I get 29 pi over 12. That's one answer. To find a negative coterminal angle, I subtract a complete revolution, or a multiple of a complete revolution. That'll give us 19 pi over 12 negative. Two possible answers for this. Supposed to find one positive angle and one negative angle that is coterminal with this angle. To find coterminal angles, all you have to do is take a complete revolution and add it or subtract it. Since we're in radians, we're going to be subtracting or adding 2 pi, or a multiple of 2 pi. So we take our 11 pi over 6, we add 2 pi to it. We want to have common denominators, so we're going to add 12 pi over 6, which is the same as 2 pi. 11 pi over 6 plus 12 pi over 6 is 23 pi over 6. That's one possible answer. To find a negative coterminal angle, we subtract a complete revolution, which would be negative pi over 6. Those are two possible answers. Next problem, we have negative 310 degrees. If we add a complete revolution to that, which is the same as 360, that would give us 50 degrees. If we add a complete revolution to that, minus 360, we would get negative 670 degrees. These are two possible answers out of a possible infinite number of answers. 29. Find the reference angle for each angle with the given measure. A reference angle is defined as an acute angle, that means it's between 0 degrees and 90 degrees, formed by the terminal side and the x-axis. Negative 30 degrees would go clockwise, putting us in quadrant 4. Therefore, the reference angle would just be 30 degrees. Supposed to find the reference angle for 12 pi over 5. And to figure out where 12 pi over 5 falls into the coordinate plane, you might choose to find a coterminal angle to do that. The reason that you might choose that for this problem is because 12 pi over 5 is more than one complete revolution. If I subtract a complete revolution from this, which is the same as subtracting 10 pi over 5, that gives us 2 pi over 5. You figure out where that falls in the coordinate plane. Positive x-axis is 0 pi over 5. A complete revolution would be 10 pi over 5. Half a revolution would be 5 pi over 5. Halfway between 0 and 5 is 2.5. So 2 pi over 5 falls into quadrant 1. Looks like this. That's your reference angle. It's acute. It's formed by the terminal side and the x-axis. The reason that we know it's acute for a radian measure, acute in radian is bigger than 0 degrees radian, is bigger than 0 radians, and it's less than pi over 2. Pi over 2 is the same thing as 90 degrees. Find the reference angle for each angle with the given measure. 130 degrees falls into quadrant 2. The reference angle is the angle formed by the terminal side, which is this right here, and the x-axis, so that it forms an acute angle that would make this acute angle 50 degrees, because 130 plus 50 would give us the 180. So this reference angle is 50 degrees. Find the reference angle for each angle with the given measure. We have negative 210 degrees, which is going clockwise. 90, negative 180, negative 210. That puts us in quadrant 2. We want to know what this reference angle is, which is this red angle here. If it's negative 210 to that terminal side, and it's negative 180 to the negative x-axis, The difference between those is 30. It's actually negative 30. But a reference angle is always acute, and acute's always positive, so it's 30 degrees. 9 pi over 4. If you find a coterminal angle, because this angle is not between 0 and 2 pi, you don't have to do this, but some people like to. We could subtract a complete revolution, 8 pi over 4. That would give us pi over 4. Figure out where that falls in the coordinate plane. Positive x-axis is 0 pi over 4. Complete revolution is 8 pi over 4. Half of a revolution then would be 4 pi over 4. Half of half is 2. Pi over 4 is between 0 and 2. So the reference angle is this blue angle here. And we went up pi over 4 to get here, so that means our reference angle is pi over 4. Negative 420 degrees. You might choose to find a coterminal angle, since this is not between 0 and 360. If we add a complete revolution to this, we get 60 degrees negative. 60 degrees negative is going in the clockwise manner. It puts us in quadrant 4, which means that the reference angle is 60 degrees. We went negative 60 to get to it, but the reference angle is always positive. 23 pi over 6. Might be easier if you find a coterminal angle. If you choose to do that, you could add complete revolutions to this, or subtract in this case. Subtract 12 pi over 6, that's the same as 2 pi. Gives me 9 pi over 6. Figure out where that falls in the coordinate plane. Actually, it gives me 11 pi over 6. 11 pi over 6 is almost 12 pi. 12 pi over 6 is the positive x-axis. The reference angle in this case would be this blue angle. So it's 11 pi over 6 to get to that terminal side, and it's 12 pi over 6 to reach the x-axis. So that means the difference between those is pi over 6. Reference angle here is pi over 6. 36, supposed to find a reference angle yet again. You might choose yet again to find a coterminal angle. So we're going to add a complete revolution to this, which is going to give us pi over 3. Positive x-axis is 0. Positive x-axis is also 2 pi, which is 6 pi over 3. Negative x-axis would be half of that, which is 3 pi over 3. Halfway between 0 and 3 it would be 1.5. 1 pi over 3 is between 0 and 1.5. So we're in quadrant 1. So our reference angle, which is an angle formed by the terminal side and the x-axis, and its acute is pi over 3. Supposed to change each degree measure to radian measure to the nearest thousandth. 55 degrees 22 minutes is the same as saying 55 plus 55 degrees plus 22 minutes. If you want to change minutes to degrees, we could write this as 55 plus 22 over 60 degrees. To convert that to radians, we're going to multiply this by pi radians over 180 degrees. Put that in your calculator. That's going to give you approximately 0.966 radians. Number 38, we have negative 110 degrees, 50 minutes, 28 seconds, which is equivalent to saying negative 110 degrees minus 50 minutes minus 28 seconds, which is equivalent to saying we have a negative on the outside of parentheses, 110 degrees plus 50 divided by 60 plus 28 divided by 3,600. Dividing 50 by 60 converts that into degrees. Dividing 28 by 3,600 converts that to minutes and then degrees. So these are all degrees, which we could write it as the degrees just one time on the outside of the parentheses. To convert that to radians, multiply by pi radians over 180 degrees. The degrees cancel then. You end up with about negative 1.935. Change each degree measure to radians to the nearest thousandth. That's 3 decimal places. 250 degrees, 49 minutes, 15 seconds, we could write like this. To convert the minutes to degrees and the seconds to degrees, take 49 divided by 60 and take the seconds and divide it by 60 twice, which is 3,600. To convert to radians, which is what the directions ask us to do, multiply it by pi radians over 180 degrees. Your degrees cancel. Shove this mofo into your calculator, and you get 4.378, approximately. That's an approximation. Get over yourself.